I would like to welcome everyone to another NEOACM Tech Talk. This Tech Talk is entitled A Comparative Analysis of Deepseek, Gemini Advanced, and ChatGPT Mini High using the Lenora Framework. This is a rescheduled presentation that we had to cancel it last month, and this is the reschedule of that presentation. Again, I would like to welcome everyone. If this is your first time, I'm welcoming you to NEOACM, our Tech Talks that we try to have once a month. We try to have one once a month, and this is the one that we're having. We're planning on trying to get a ACM distinguished speaker for a Tech Talk in May. That's what we're working on. So to let everyone know that is new, if you have any questions, put it in the chat after Trevor is done doing his presentation. We will have a question and answer. I will read your question from the chat and present it to Trevor, and he will respond. And maybe if there's time left, maybe we'll have a little more of an exchange if we have time. So I want to introduce Trevor Watkins, our speaker, and give you a little information about Trevor. Trevor Watkins is the teaching and outreach librarian at the George Mason University. He works with faculty, students, and researchers on projects, grants, and scholarships. He teaches information literacy courses and conducts library carpentry workshops for the Digital Scholarship Center at GMU. Mr. Watkins is a technical lead and chair of the Web Committee of Project STAND. He is a member of the Technical Advisory Group for the National Finding Aid Network, which is a collaboration between OCLC, the California Digital Library, Shift Collective, and the University of Virginia, and the Chain Bridge Group. Trevor's research interests are AI literacy, human-AI collaboration, STEM librarianship, information literacy integration models, open knowledge diffusion tools, and teaching and learning theories in non-traditional spaces. Trevor is a professional member of IEEE at ACM. He is also the founder of Gray Alien Technologies, where he consults with public libraries, academic libraries, and Black, Indigenous, and people of color organizations about their technology needs. Mr. Watkins holds an MS in Information Architecture and Knowledge Management and an MS in Library Information Science from Kent State University. Got a Kent State shirt on. He also holds an MS in Computing and Information Systems from YSU, Youngstown State University. Mr. Watkins has co-authored published papers and presentations at conferences and is a 2021 IMLS, that's the Institute of Museum and Library Services Fellow for the IDEA, that's the Innovation, Disruption, Inquiry, Access Institute on Artificial Intelligence. Yes. Some of his current projects are Black Squirrel GNU Linux operating system, Cosmology of Artificial Intelligence, which he's working with me and Cameron on, and MOCA, Mason Libraries Orientation Conversation Agent. Wow. Very impressive. So I would like to present Trevor Watkins, and this is going to be a very, very excellent presentation. Thank you. Take it, Trevor.
Thank you, Tracy. And I am going to pause my video because the bandwidth is kind of sketchy right now. But before I get into my presentation, I first want to thank you all for coming today. I do apologize for this having to be rescheduled. I did get sick a couple of weeks ago. So there's something going around. People at work are getting sick. So take care of yourselves first and foremost. So as Tracy said, my name is Trevor Watkins. I am the teaching and outreach librarian at George Mason University. And today I am going to talk about a comparative analysis of Deepseek, Gemini Advanced, and ChatGPT o3 mini high using the Lenora Framework. Now, most students and most people, the average person, when they're using Gen AI tools, they usually use the free version, right? So if you sign up with OpenAI, you have a couple of versions, that are free that you can utilize. But this presentation is on the paid versions of Gemini Advanced, the paid versions of ChatGPT. So o3 mini high is the there's a lot of different versions, and I'll show you all that later when we kind of go through those. And then also DeepSeek, which is obviously open source, and it is free to the public. What's really interesting about that, which I'll talk about later, is it actually has a lot of the same functionalities as Gemini Advanced and ChatGPT 3, o3 mini high, considering that those are paid versions. It actually has a lot of the same features in its free version. So that's one of the reasons, if you've been following DeepSeek, why it disrupted the markets the way that it did. I think it's first and foremost, it's important to acknowledge my positionality and the lens through which I see the AI and education field. I am a Black male working in the information science, computer science, and engineering field, and I work at an R1 academic institution in an academic library. I teach critical data literacy workshops and engage in diversity and BIPOC-related digital projects with faculty, students, and the broader academic community across the country, some of which Tracy already talked about. I am also a researcher and practitioner in AI and data science. Actually, last year I did 26 presentations. Most of those were invited, so it was pretty busy. And this presentation is based on my experience using these tools and working with students and faculty that use these tools at George Mason University. I also do teach part-time at Youngstown State University. So I've also allowed students to use it in the classroom, which has been pretty interesting. I'll talk a little bit about that a little bit later. But I always embrace new technologies with skepticism. But I've learned how to mitigate that skepticism in the name of objectivity. And so really coming up with this framework and analyzing and comparing these three generative AI tools, I tried to be as objective as possible. And I think finally, it's also important to note what this presentation is and is not. The focus of this presentation is the framework, the metrics, and evaluation of the three Gen AI text-based tools that I just talked about, and how it is used in the LIS field, library science, but is also obviously applicable to other fields as well. So here are learning objectives for today. At the end of this presentation, you should be able to define the 6 components of the Lenora Framework and explain its role in evaluating generative AI tools like DeepSeek, Gemini, and ChatGPT, but you can also apply this to other Gen AI tools like Perplexity, Claude, and some of the others as well. You should also be able to apply the Lenora Framework to conduct a structured comparative analysis of AI tool used in research, writing, and instruction. And this is what I base it on because this is how I engage with faculty and students at the university. So I'm basing it specifically on that in research, writing, and instruction. You should also be able to map Lenora's components to the ACRL Information Literacy Framework, identify how AI tools impact students' understanding of authority, research as inquiry, and strategic searching. Those last three are three of the 6 frames that I'm going to talk about in regards to the ACRL Information Literacy Framework, and that is how librarians like myself and educators use to teach information literacy, which is really important. And you should also be able to integrate AI literacy into library instruction or classroom teaching. So if any of you are teaching classes, you don't obviously have to be a librarian to utilize this framework. But I'm going to talk about not only the framework and the components, but also the metrics by how they're being compared and analyzed. Also, I'm going to talk about the history of AI in education. And this is something that I found really crazy just talking to students and even researchers and faculty. A lot of people don't realize that AI in education goes all the way back to the 1950s and even further than that. They think now because we're using Gen AI, now we're using AI in the library or in education, and that's just not the case. It's been used throughout history. And we'll take a brief look at a timeline, which I think is really important too. So here is one part of the AI in education timeline. So most of you that are on this call, I know for sure that are already AI practitioners, and or computer scientists and know the history. But for those of you that are not initiated, during a conference that was organized by John McCarthy in 1956, McCarthy actually coined the name artificial intelligence to distinguish the field from the existing cybernetics field and to emphasize the focus on simulating aspects of human intelligence. So here is a link that I am going to provide in the chat about that event in Dartmouth. So I'm going to copy that link. So if you want to take a look at that. Second. This gives a history about that actual event, and it also talks about a lot of the stuff that Dartmouth is doing today with AI. And I just published an article. I co-authored an article with an associate dean of Dartmouth Libraries, and we talked about it was about machine learning and AI and how to talk about it with patrons. And that was based off of a conference we did last year at NESO Plus in Baltimore. And so one of the editors from one of the special journals came up to us after our presentation and asked us if we wanted to take that presentation and turn it into a journal article and we also obviously we did that. But they're continuing to do a lot with AI this day. So first in 1960, we had the early computer-assisted instruction, or CAI systems like Plato. Plato stands for Program Logic for Automatic Teacher Operations. That allowed for interactive learning experience at the University of Illinois. Here is also another link to Plato to get some understanding about that. And that's actually at the Distributed Museum in Illinois. I'm going to place that link into the chat as well. So if you want to know a little bit more, you can go to that. Also, the first chatbot, which was named Eliza, was an actual chatbot therapist. And that was created in 1966. And it simulated conversations through pattern matching. Here is a link in the chat where there's two people who actually brought this back to life, but they use JavaScript. Let me copy this. Give me 1 second. I'll put that in the chat too for y'all to look at. But Michael Wallace is the person that actually created the JavaScript version of ELIZA, and then George Dunlap enhanced it at the New Jersey Institute of Technology. So if you go to that link, you'll be able to actually play around with ELIZA. And this is sort of what it looked like in 1966. In 1970, we had intelligent tutoring systems, or ITS. That's when that development began, and it was aimed to provide personalized instruction. And this is one of the first practical applications of AI in education. In the 1980s, the PC became more integrated into classrooms. You had specialized AI programs like CircSim that were used for medical training. Specifically, CircSim was an intelligent tutoring system for the domain of cardiovascular physiology. And AI in education, or AIED, emerged as a distinct research field during that time as well. In the 90s, we had ALICE, and the acronym for ALICE is Artificial Linguistic Internet Computer Entity, which was a natural language chatbot that engaged in conversation using heuristic pattern matching rules to the user's input. All right, so that's a little bit of about the timeline. I'm going to talk a little bit more. Between 2000 and 2010, we had new fields emerge, like educational data mining and learning analytics. You all probably are familiar with Khan Academy and Coursera. Those were launched, Khan Academy specifically in 2006. And then chatbots became more sophisticated with natural language processing advancements. You also had Alexa and Google Assistant and other similar AI tools that were created. And obviously, OpenAI released ChatGPT in late 2022. And that obviously threw everything into a loop. It disrupted, definitely disrupted education. I know at George Mason University during that time frame, a lot of professors were running around trying to figure out what to do. They contacted the library to try to kind of gauge, how to, utilize it in the classroom. They looked for the university brass to, were there any policies? And they actually looked at the government in Virginia to get information from them. And when that didn't come, our library actually took the initiative to create an AI council, an AI community of practice, an AI salon series. And so we began to sort of integrate AI into the classroom, but also spark up conversation and start to test these tools and work with students and work with professors who wanted to actually use them. All right. Major tech companies obviously started to release competing models like Google Bard, which is now Gemini, and Khan Academy now has its version of an AI tutor called Khan Mingo. Between 2024 and now, AI tools are embedded in learning management systems and educational software. So if you are familiar with Blackboard, I think there are some, some professors, some adjunct professors, some full professors maybe on this call. If you're not aware, Blackboard does have an AI or generative AI component. It can auto-generate modules. I have not played around with this myself yet. And at George Mason, we just migrated from Blackboard to Canvas. So we can add Gemini as a third-party app. You can integrate it within Canvas, and you can use it to also help to generate, modules or assignments and those kind of things as well. So it is everywhere. It is integrated into just about everything. All right, so AI was ubiquitous before the release of ChatGPT. I know a lot of people sort of look at ChatGPT and say, okay, AI is now here. Well, that obviously that's never been the case. AI has been here since, as I talked before, since the 1950s. But it is much easier to see for the uninitiated or average person now more than before. Generative AI is now in just about all software used at universities and beyond. You know, we can go on and on. Microsoft Copilot, which is what George Mason University has access to because we are an Office 365 shop, unfortunately. But Copilot is a tool that we're using university wide. You see this in Adobe Suite, and a lot of our students use Adobe. Graphic design tools like Canva, cybersecurity tools like Splunk, and there's many other tools as well. You see this in healthcare, you see this in government, which is why, in my opinion, it is a must that we prepare students for what they'll see in the workforce and increase the awareness of the general public. And this is something that we discussed, um, during 2022 when ChatGPT came, because a lot of people were afraid, and they're still. I mean, we've had students cheat, and you still have some professors where they allow it in the classroom. Some still do not. But the university, basically, at least at George Mason University, leaves it up to the professors or the department to determine whether or not to utilize it or not. All right. Okay, so the role of librarians and educators, and this is much of what I and many other librarians at GMU do, is to understand how AI works, its capabilities, its limitations, and then we try to teach students to become critical, responsible, and ethical users of AI. This includes evaluating AI-generated content, understanding bias, and citing AI use appropriately. You probably have also already saw that um, you know the publishing industry initially did not accept generative AI. Um, and I don't recognize AI as an expert authority or an author. However, some publishers or a lot of publishers now do, and some professional organizations do. You do have some organizations like the ACM and IEEE that treat AI as non-authors, but they do now require you to acknowledge its usage in any submitted works. And after much initial pushback, generative AI is now considered a part of the publishing landscape. So it has now creeped into the publishing landscape. There is no way around it because people are actually using it. And if you've looked at the news, you see a lot of people attacking presidents of universities that's used generative AI to generate a speech. This happened to the president of UMD, and this is public information. But this has also happened in other instances. So I don't know if that sort of fast tracked, well, now generative AI can actually be used. But it is here. It's in everything. Now it's in our publishing landscape. If you're using APA writing style or MLA writing style, they now have a portion of that where they talk about how to cite generative AI tools. All right, so this is actually a good segue into the Lenora Framework. So there's quite a lot of publications out there in relation to how to compare and contrast generative AI models, which much of it is based on the technical aspect of large language models. However, I couldn't find any particular frameworks that could be used by professionals in the information science, library science, and education fields. So I created one after looking at several classes I co-taught or led based on feedback from both students and faculty through surveys, so like pre-assessment, post-assessment surveys, and other data that I collected. Usually if we gave them assignments to do, take home after that session and come back, we gathered data based off of that. Each letter in the acronym represents a key evaluation criterion for comparing and contrasting generative AI models. So if we start with the letter L, which is learning capability, um, we look at how well does the model understand research questions and concepts. So if you're evaluating any of those tools, whether it's ChatGPT or DeepSeek or Gemini or Perplexity or Claude, how well does the model understand research questions and concepts? Does it improve responses over time? Does it remember a previous interaction and relate it to a new inquiry? So these are some of the things that we do as human beings when we communicate with one another. A lot of that communication is based off of memory. So we look at so I look at these tools to see if it actually has the same capabilities. And so for the metrics, a score of 1 to 10, 1 if it freezes up, does not respond or forgets, and to 10 if it answers immediately and is able to retain context. And I'm sure some of you, when you've used and tested these tools, you probably had situations where it actually froze up on you, did not respond, give you the desired output. In some cases, that could be a part of your prompt engineering. In other cases, it may just be a fault of the actual AI model itself. All right, for the next component, E is explainability. So does the tool justify the output of a prompt without having to be prompted to do so? So in other words, if I ask any of these tools, um, can you write a paper about the nature of surveillance, and write a 3-page paper? It should, and we're taught, and educated to obviously cite our sources, have a reference list and cite our sources. So does the tool justify the output of its prompt? Does it actually cite those sources? Does it provide those sources? Does it provide references or reasoning for its responses? If so, how accurate? And so in terms of metrics, look at the percentage of responses with proper citations versus fake or made up citations, or if it doesn't generate any citations at all. And so that's the metrics in which, that's evaluated. N stands for natural language processing, which again is understanding and also generation. So the question is, how coherent are the tool's responses to prompts? Does it handle complex prompts? Right? So some of the prompts can be more complex than just asking it to write a paper. You may ask it to, write a mathematical equation, and maybe you're working on a new proof. Does it handle those prompts complexity? Can it handle ambiguity and also multi-turn conversations accurately? In other words, can it mimic natural human conversations? So if you think about conversations that we have, in some cases, we have to, have an exchange between us before we're actually able to understand what one or the other is actually saying if we're talking about a specific topic in some cases, right? So how does these tools handle multi-turn conversations? So the metrics for that is grammatical accuracy. So the percentage of cohesion and coherence, does it stay on topic and does it make sense? Also, can it resolve ambiguous prompts? So a way of testing it is to actually give it vague questions to see if it actually returns an ambiguous response. The O stands for optimization. So how quick are the AI tools' responses to prompts or complex prompts? How does it perform under certain tasks that students are most likely to give it? Generating code, brainstorming, summarization, those kind of things, or those kind of tasks. How does it handle multimodal input from users? So again, if you think about how we naturally interact with the world, we use a combination of senses to understand and respond to our environment. So for generative AI, multimodal inputs could be text, images, audio, video, code, all those things simultaneously. And then the metrics is to basically measure the average response time between prompt and response over multiple inquiries. So if you're using the free version of these tools, it's a little bit different when you're using some of the other features of the paid version, which we'll see when I show you. Because in some cases, if you're using some of these more advanced features, it may take a little bit more time than it would usually. And from my experience in the classroom, if students, similar to if they're on a website and it's text heavy, they're prone to not to kind of leave that website and go somewhere else. If it's taken too long for the AI to or for the AI to respond, that can turn students off, and obviously that was feedback that we received from the survey. But some of these tools, can take a long time if you're using some of the more advanced features of it. Also, reasoning. How well does the AI tool handle analytical tasks, and can it think critically? How well does it handle complex mathematical problems? Can it code efficiently? Does it hallucinate or show bias in its reasoning? And one of the things that you'll see differently from the free version versus the paid version of Gemini Advanced and ChatGPT is it now shows it actually reasoning. Deepseek does this automatically without you actually having to pay for it. So if you put something in a prompt, if you have some kind of complex prompt, or even if it's a simple prompt, it will show you visually how it's actually thinking and reasoning, which is something I think is pretty cool to see. And this is something also that the students like to see as well, and researchers as well. Also, and so the metrics to measure is to measure the correctness of AI generated code is the syntax. Do you have any syntax errors, any logic errors, or any runtime errors, especially if you're using code? I think in the last one of the ACM meetings, we had several people that are using it. I've used it to see how well it actually performs when coding. In some cases, it works efficiently. In some cases, it actually fails. And I see a lot of situations where there's a lot of logic and runtime errors, not necessarily syntax, but more logic and runtime. And so that's how that metrics was designed. Also, we have adaptability, which is the final acronym in the Lenora Framework and the final component. How well does it actually adapt to different use cases? In other words, if you start out with coding and then switch to research and then ask it to create content, is it able to do this effectively and then come back around and answer questions from memory, similar to how we communicate with one another? How we can sort of go from one task to another task that's completely non-related, but also be able to come back to the original task or one of the other tasks, as we're conversing or exchanging ideas. And so I wanted to see if it's possible for any of these tools to be able to do that with my interacting with it. And so the metrics for that is based on recall percentages. So the ACRL framework. So the ACR framework is how librarians and educators teach information literacy. Information literacy, and this is very important, it is a prerequisite of AI literacy. I see this oftentimes, and I've looked at a lot of publications, a lot of journal articles that talk about what AI literacy is, and it seems to me that it leapfrogs information literacy. I was interviewed by the Library Journal, and the editor, or I'm sorry, not the editor, but the reporter who was writing the story kept talking about AI literacy. And one of the things that when we got into an argument over the phone, and I was like, you can't leapfrog information literacy. Do you understand that over 130 million Americans read at a sixth grade level? So if you're reading sixth grade level, that means you're not going to be able to find information the way that you should be able to find it. You're also not going to be able to navigate through misinformation, disinformation, and malinformation, right? And so if you're not information literate, you can't just leapfrog and go to information literacy. So the ACRL framework is what we use to teach students every day how to become information literate. And so here are the 6 frames. So we first have authority is constructed and contextual, which means that authority is not absolute, it's shaped by context. We also have information creation is a process, which means that information is created in different ways and formats, each with varying purposes and values. Some of those purposes are malicious. We talk about misinformation, disinformation, and malinformation. And when you look at how information is created, you have multiple perspectives, right? That's also important. Next, we have information has value, which means that information is a commodity. It's a means of education, and a tool for influence. Information has economic, it has social, it has political, and it has ethical dimensions, right? Research is iterative and involves asking increasingly complex questions. So that's research is inquiry. And then we have scholarship as conversation. So anytime that you access the ACM library or the IEEE library, for those of you that are on the call that are computer science, IT, or computer information systems, or if you're in that field and you use IEEE and ACM, you can look at a particular topic and you'll have different researchers have different perspectives on that topic. So this is scholarship is conversation, right? And so this is one of the things that we try to impress upon students when they're actually writing papers. What type of new knowledge are you bringing to the field? What are you adding to the conversation, right? And so that's what scholarship as conversation is. Knowledge is built over time through ongoing dialogue among scholars, students, and communities, and that's really important. And finally, we have searching as strategic exploration. That is effective searching, which requires curiosity, persistence, and a flexible approach. So for those of you that's written a journal article before, you know how rigorous that is, or if you've written books, that's very rigorous. You have to go through a lot of material, reading material, reading other articles. That can be laborious, right? But it's still a part of what you have to actually do. And this is necessary to learn before touching any Gen AI tools, right? You have to understand how to search for information. You have to understand when you're looking at results. However, a lot of students, this is one of the other things that we have in the survey, in our pre-assessment survey. How do you find it? How do you look for it? What do you look for information? A lot of students, especially first year experienced students, they usually use Google. And so we have to teach them, okay, even though it's behind the paywall, here are journal articles, here are specialized databases where you're going to find scholarly articles, which is very important. All right, so here is a table, and this is a brief comparative analysis of Gemini, Deepseek, and Gemini Advanced. And again, this is used in research, writing, and instruction. So break it down by category, and then we have Deepseek, we have ChatGPT o3 Mini High, and Gemini Advanced. So in terms of learning capability, Deepseek handles context pretty well. It's excellent in multi-turn dialogue, which I talked about before, and what that is. Within the same chat or thread. However, if you've already used ChatGPT or Gemini or DeepSeek, you know that you can start a new chat. What I find is when I try to start a new chat and then try to reference something from a different chat previously, it has a hard time with memory. But if you're in that same chat or within that same thread, which is another thing that they call it, it is able to recall it pretty well. Same thing for ChatGPT. It has excellent memory and multi-turn dialogue within the same chat or thread. However, if you start a new thread or if you start a different chat, which is what we do as human beings, it struggles to memorize that or to be able to recall that information. And so what I found, and the same thing with Gemini Advanced, is it'll either freeze up, it'll say, I don't remember that conversation. But then if I go back to the original thread where I was talking about it and I pose that same question or I pose that same inquiry in the prompt, it'll be able to obviously recall that. In terms of explainability, DeepSeek has some citation awareness. It still hallucinates, but I find that the hallucination is actually less than ChatGPT and Gemini. ChatGPT o3 Mini High has strong justification and transparency. It has some citation awareness. Some of the updates since 2022, where it now has access to the internet. If you remember in 2022, 2023, it was based off of the corpus that it had up to a certain date, and it was based off that. Now it can actively search the internet and then do an analysis based on that. It's still obviously using training data from your input. So if you're using any of these tools, it's using your training data, and it's also using its original corpus and any corpus that they add onto it. It's black box, so we don't know what that corpus is with ChatGPT and Gemini Advanced. But there is some citation awareness now as opposed to before. But it still hallucinates quite often in some cases, especially if I ask it to justify its response or cite its response where it got that information. In some cases, it'll either make up that response or it'll post or it will actually point to a website that has nothing to do with the inquiry. Gemini Advanced has a limited citation awareness. It's pretty decent with citation, but it still hallucinates as well. One thing that I actually thought initially is that um, I wondered if, how it actually would work across the entire Google ecosystem. However, because I've used Google and used PowerPoint and, all of the different things, Google Doc, obviously I don't want all of that information put into their training data. Um, yeah, so I'll see some questions in the chat. I'll ask that in a minute, or I'll answer those in a minute. In terms of optimization, Deepseek has pretty fast output. It's lightweight. With ChatGPT, it's moderate speed to lower speed. It just depends on the feature that you're using. So if you're using O3 Mini High, which is its highest and it's the most it's most advanced, and it's O3 Mini High is specifically more for coding, but it still can answer questions at at a high level. But it does it at a moderate to lower speed, but the output is higher quality. Gemini Advanced has a faster output. In regards to reasoning, it's good with structured tasks. It's not good, again, it's not good with recall if you start with a new chat. ChatGPT is excellent at reasoning and problem solving, but not good with recall, again, if you start with a new chat. And same thing with Gemini Advanced. In terms of adaptability, all of them are excellent with multiple languages. So a lot of our students at George Mason University, we have over 120 different languages from students that are there from all across the world. So these have been good tools for them to actually use. And so you can prompt it and ask it to put the output in several languages, and it will do it simultaneously, which is a really good feature for students. And if you think again of how we interact, some of us are bilingual, some of us speak multiple languages, and so we're able to switch in and out of languages. And so this is something that each tool also does very well. So in this next slide, I want to talk about how the Lenora framework intersects with the ACRL framework. I already told you about how important that is. And again, the related Lenora component, we have the learning capability. The related ACRL frame is the information creation as a process. Scholarship is conversation, and how it intersects. The model that retains context and learns from interaction helps users understand research as an iterative process and participate in scholarly dialogue. In terms of explainability, the related ACRL frame is authority is constructed and contextual, and information has value. How it intersects with Lenora is it helps learners assess how AI establishes credibility, cites sources, and reflects on information ethics and intellectual property. In terms of natural language processing, research as inquiry, scholarship as conversation, which is the related ACRL frame. It assists users in asking better questions, recognizing how language shapes understanding, and contributing thoughtfully to academic discourse. In terms of optimization, the related ACRL frame is searching as strategic exploration. How it intersects is it encourages learners to understand that tools vary in efficiency, depth, and scope, which influences how they find and use information. Reasoning, the related ACRL frame is research as inquiry, where authority is constructed and contextual. How it intersects is it promotes critical thinking, supports iterative inquiry, which is important, and it helps evaluate the reasoning behind information claims. And finally, adaptability. The related ACR frame, information as value, search as strategic exploration. It shows how information tools must be adapted for different disciplines, languages, and ethical contexts, and it reinforces strategic tool selection. All right, so we're going to stop here. I'm going to stop my share. I'm going to go to these tools. Give me 1 second while I set that up. Okay, we're there. Is that it? I think this is it. Okay. Can y'all see that? Okay, so we're on ChatGPT. So most of y'all are familiar with the GPT 4.0. GPT 4, I think they're getting ready to slowly transition out of that. But this is the paid version. So these are the different models that's available if you're paying $20 a month. And there's also another tier, which, is way too much for, for my pockets. I think it's $200 a month. But again, I'm using this specifically for research purposes, and this is the library paid for that. So it's not coming out of my pocket. But GPT 4.0 is great for most questions. GPT 4.0 with scheduled tasks. This is again experimental. GPT 4.5, good for writing and exploring ideas. O1 for advanced reasoning, O3 mini which is supposed to be fast at advanced reasoning, and then O3 mini high, which is supposed to be great at coding logic. And then some of the other models we have is GPT-4 mini, and like I said, GPT-4, and they're actually leaving in a couple of weeks. They're phasing that out. All right. So I'm going to ask it a couple of questions, and I'm going to show you exactly what I mean by, so let's say, let me see, create a research paper exploring the history of calculus and provide references. So as you can see here, it shows you that is now reasoning, planning the research paper. And it's telling you, it's saying, okay, the user is asking for this. I need to produce a detailed research paper style response using my knowledge base, citing reputable sources. I don't have to rely on, and then read the rest of that. But as you can see, it's kind of going through, it's showing you sort of behind, at least from their standpoint, the behind the scenes of what it's doing before it actually creates this paper. So it's showing you the reasoning that's happening. So it took 45 seconds. All right. And as you all know, this isn't, well, depends on what journal that you were actually writing. It wouldn't be in this particular format. But let's see if it actually cites its sources. Let's see if it does that. I don't see any in-text citations. Here's the references. But one of the things that is actually lacking here is in-text citation. So while it does say here are these references, and one thing that we do is always check to see if these references are actually legit, which I won't have time to do that today. But the problem is there are no in-text citations. So let's see if they'll actually provide that. So now it's adding in-text citations in. Let's see if it does that. So it said it didn't include it. Now it's going to include it. All right. And this looks like APA. So again, don't have time to actually go through and determine whether or not those citations are correct or if it's made up. But as you can see, right off the bat, when I asked it to write the paper and provide, references, it did not include in-text citation, which is something that is basically foundational when you're writing a research paper. All right. And so these language models have now been out for a couple of years now. You would think that that was something that, you wouldn't have to prompt. Let's try the same thing in Deepseek and see how it performs. And so if anybody at George Mason University watches this later, because we're banned from using Deepseek on our machines, or at least on university-owned machines, this is my own personal device that I'm using it on. So yeah, DeepSeek has been banned because the fear is that the Chinese are going to be stealing our data, which is exactly what Gemini and ChatGPT are already doing, and all of the other platforms. So basically, it's, who are we going to allow to have access to our data? But I'm going to go ahead and so for those of you that's never used DeepSeek, here are some of the different versions. These are free. You can get the DeepSeek app. The API, if you want to use their APIs, that actually costs, but to actually use the actual tool, there is no cost. So I think that's probably one of the things, one of the reasons why disrupted the market, and it performed better in a lot of cases than its counterparts. So I'm going to post the same. So if you remember, ChatGPT took 45 seconds before it began writing. DeepSeek immediately began writing. And DeepSeek, without me asking it, again, I would actually have to test or check to see if the references or the in-text citations are correct, but it automatically included the in-text citations without me asking it to do so. Okay. Let's try the same thing in Gemini Advanced. So for those of you that haven't used the paid version of Gemini, it also has different features. So you have Flash, which is for everyday tasks. It has other features. Then you have Flash Thinking, which again is experimental, which uses advanced reasoning. 2.5 Pro, this just actually came out a couple of days ago. So I've just now actually had the chance to test it. Deep research, this is if you want to get a research report. I've tried this. It may take, in some cases, it could take 30 minutes to an hour for it to actually produce the research report. However, it is pretty comprehensive, but it still, in some cases, has faulty information within the report. And you have personalization. I've not actually tried this yet, but this is supposed to be based on search history. So I'm assuming that probably has something, and again, I haven't used it. I'm assuming that probably has something to do with um, your Google search. So if you're signed in like I am, which I'm not going to use that. And again, this account is doesn't have all of my stuff in, so I'm good to use it. So I'm going to ask it to do the same thing. So like DeepSeek, it immediately began to write, but like ChatGPT, it did not include in-text citations. So I'm going to ask it to do that. Let me see if it's actually done. Something went wrong trying to reload the page. Uh, let's try this again. Maybe it's still writing. Yeah, it's still writing. That's why. So no, it should be done. So it's showing you what it's thinking about. All right. So one of the things that's different between the two is it noted that abstracts, which they don't typically require citations. And then of course it's added those in. But I had to prompt it to do that. Okay. So I'm going to start another chat. Well, this part I'm going to see if it actually is able to revert back to or recall the previous conversation we have or the previous inquiry in the previous thread. So how many words create the it says there is no calculus, there is no calculus question in this conversation. I'm not sure which calculus paper you're referring to. I don't have a record of a calculus paper question. So now I'm going to go back to the previous. I think I'm going to go. Okay. So if I go back to the previous thread, then it's able to recall it. But if I go to a new thread or a new conversation, it's not able to recall the previous thread. So this is, to me, this is um, one of the weaknesses of these AI models, and this is the same with DeepSeek, the same with Gemini Advanced as well. All right, we're getting close to the end, so I'm going to close this. All right, so any questions? All right, so I see a couple.
Okay, Trevor, first of all, let me just thank you so much on this fantastic presentation. We really enjoyed it, and it's a number of questions. I would like to start with, could you post a link to the Lenora Framework? Could you post
Oh, I
that?
don't have it available online yet. Um, and I'm actually writing a journal article. I see someone actually provided so I'll take a look at that, Aaron. Thanks for posting that. But I'm still I don't have it like I don't have it like posted anywhere yet. But once it is, I'll send the link to you to it.
Okay, so I'm gonna just go ahead and go in order. I know me and Cameron had a question, a question initially. Our question was, are we equivocating routine computer calculation or computation with the term reasoning? These programs showing their calculation methods don't necessarily boil down to reasoning, does it?
I'm sorry, say again.
And reasoning. Are we equivocating computer calculation and computation with human reason?
That's a really good question. Um, I think that if, you know, so I think the point of AI is to try to get the computer to mimic human intelligence. So, how can we best do that?
Okay.
We can we do it algorithmically, we do it statistically. And is that not, I mean, isn't that how we create these models?
Okay, so we're going to get into the weak, strong thing.
I mean,
As
even if we talk about human reasoning, um, it's not just logic, but it's also emotion, which again, that's not something that and I think we might have talked about this the other day. One of the things that none of these tools can capture is emotion. So when we use reasoning, a lot of that reasoning can be logical. Some of it is emotional. In some cases, it's with context, without context. It can be influenced by a number of things. Um, so I think that, that's a really difficult thing to answer.
I mean, the
I don't
history
know.
the history of AI, as far as, are we going to try to mimic the way human beings do a certain thing? Okay. Are we going to try to model that and mimic that? Or are we saying we're looking at the results and then we come up with whatever computational methods that we need in order to produce that result? Then we're saying, well, this is what computers do, and we have this result. We could compare that result to what human beings do, but it's something totally different to say we're modeling the way humans do that task, as opposed to just we're trying to get a result. So we do this anthropomorphizing all the time, but it's Are we looking at the result, or are we looking at the process?
I know that y'all say, we've had a lot of conversations in some of these meetings where we talk about deductive reasoning and inductive reasoning and abductive reasoning. So when we look at those particular premises or principles of reasoning, and that's supposed to be fundamental to human cognition, but obviously, as you all know, that you have behavioralists that think about this in an entirely different way. Right. Aren't these models supposed to simulate aspects of that process?
Here's a thought. So your talk is specifically on DeepSeek and Chat and those types of computer programs. Those things are largely based on statistical models and statistical processing. And so why do we even use terms like reasoning when all we're talking about is a certain kind of statistical optimization? You know, why don't we just refer to the kind of computation that it is? Why bring in terms? And I know you're not the person that's bringing these terms in, but why bring in terms like reasoning and hallucination that have to do with the states of the human mind, right? When we are really talking about programs that do statistical modeling and optimization and statistical pattern matching. That's really all that's going on. And so mathematicians that would look at the inner workings of DeepSeek and Chat3 and all of these models, they're just going to see a number of statistical, of optimization techniques and probability matching. They're not going to say anything like what goes on in the human mind. So I think the question is really trying to get at why are we anthropomorphizing this kind of mathematics? It's nothing like what the human mind does. So what's going on?
No, I don't disagree with that, but when you say statistical reasoning, doesn't statistical reasoning and also involve drawing inferences or making predictions or testing?
Yeah, there's a whole
based on data.
Yes, there's a whole field of mathematics or statistics called statistical inference, and that's about optimization. It's not about reasoning, right? And so, we're equivocating those words, right? There's a difference between the optimization that goes on with in statistical inference and the kind of moving from premises and propositions to conclusions that goes on with human reason. It's a very different kind of activity. They both have the word inference in, but that word inference means something very different. And I think we're that's just part of the confusion. I think when you're using the word reasoning and hallucination, then we need to have, if we're going to use those terms, then we need to talk specifically about how they're defined in the world of computer science, which is very different than how they're defined in the world of psychology or psychiatry or in cognition. Does that make sense?
Yeah, it does. How is that?
Because when the layman hears the term reasoning, they start thinking human conscious awareness, and they bring that word implies a lot of things that really aren't going on at all. The process that the kind of computation that these language models are doing has nothing to do with a priori knowledge or posteriori knowledge or a knowledge from experience or actually sensors that experience the world. It doesn't have any sense of context or environment. It doesn't have any of that. This thing is taking a one set of data and it's using optimization techniques to determine how it matches to another set of data. And there are no sensors involved. There's no experience involved. There are no psychological states involved, but we call it reasoning, right? And so when a layman hears that term reasoning, they think reasoning like humans or like animals or pets or some living thing reasons. And these we're not talking about that. We're really talking about really fundamental statistical calculations here. And that and to be quite honest, are not anything like the kind of processing that goes on in the human brain. And I don't want to detract your time here again, because this is a whole can of worms. Just the question is what, as we're looking and talking about reasoning and things like hallucinations, and then when you say those words in a layman context, what do they take away from that, as opposed to just
I think that that's something that the computer science field need to do a better job of.
yes.
Because if you look at
Yes.
a lot of papers that I've read, what you're saying, they're not saying.
Right. Exactly.
Right. So, and I think when you look at reasoning across other disciplines, as you just said,
Yeah.
They're kind of equivocating those things as similar.
Yeah.
But there isn't any pushback, or there isn't anything, at least from what I've seen,
Yeah.
presentations I've been to, and from the literature I've read, where they're actually talking about that and talking about it in that context.
Yeah, they'll just accept it whole cloth. Oh, sure.
Oh.
Sure. Not only is Deepseek reasoning, but it has the ability to explain its reason.
Okay, I'm gonna go to the next question. Aaron had a couple of questions that he wanted to present to you, Trevor. Aaron, would you like to present your
sure.
question?
Thank you so much. Well, fantastic presentation, Trevor, and the gentleman next to you, Tracy. I don't know your name, but great question. Yeah, and I think it'd be great if you had a talk on that at some point, because I do think there's almost like a COVIDization that's gone on with AI, where it just nobody wants to call the elephants in the room, because obviously it's not even just economics. It's almost become psychological.
Right.
It's just like, if you see it happen in sports all the time. You see it in all kinds of other areas where it's sort of like we've jumped the shark. It's the eighth season of Happy Days, right? It's the one we don't need, and or every other thing that they pump out. So my question to you, Trevor, is once again, amazing presentation, and actually in some ways you are proving. And I don't know the gentleman next to you, Tracy. What's his name?
Cameron, yes.
Oh, okay, Cameron. Yeah, you're sort of proving his point in that we've gone down this, I mean, incredibly robust deployment cycle with a technology without sort of any. I mean, I've never seen this in my career. I've been in at the commercial level for 30 years, and before that, kind of at the high school, college, kind of stumbling through the dark level, just getting myself there. And I've never seen any technology of any magnitude deployed at any scale like this, that just doesn't have any sort of what you'd call guardrail benchmarks of anything, right? Like, if actually not even, I don't mean, when I say benchmarks, I don't mean necessarily raw performance, but functional performance, right? Like boundaries, right? We wouldn't deploy an ERP system, an enterprise resource planning system, in any vertical space that couldn't, that would have this sort of random volatility of performance of critical transactions, and so on. So once again, thank you for that. And I look forward to your framework coming out. My broader question was, obviously you're benchmarking these models. Are you looking at additional open source models? And also, is there any kind of initiatives, which I just don't see out there, to bring these things in-house? I see it in the commercial side, like I work in industrial automation technologies and robotics, stuff like that. So everything is in-house, really. Like no one's going to use sort of cloud-based external proprietary search tools. I mean, just because you can't, it's just your data and your plant line, your assembly line, so sensitive. But so we're figuring out how to use different open source models, sort of inside the firewall. But I don't see that happening kind of in the academic setting, which sort of puzzles me because in large universities, you have huge customer bases, right? End user bases, tens of thousands, which aren't free. I mean, they cost you money per seat licenses, which when you do the economics, rolling out, kind of rolling your own through GPUs and open source models and a GPT, kind of wrapper, I don't know, just seems to me to make a lot of sense. Maybe I'm just nuts here and don't get it, but is that, am I missing something here, or is this something, or is this just classic? And I mean, this is sort of a joke, but like university bureaucratic Doge issues, right? Where you just can't get everyone together, right? Like, and so someone makes a call and says, Microsoft Copilot, boom, go out the door, good luck. Is that what it is? And I just don't, and that just can't be overcome. I don't know. Hopefully that makes some sense, which is sort of like,
Oh,
what?
it make a lot of sense.
Yeah.
So based on your first question, yeah, I am going to be looking at a lot of the open source LLMs and put those in that framework as well. And as far as GMU, they're supposed to be developing. We are supposed to be developing our own large language model, but they do want students, because we're already in O365
Yep.
campus. They want to, because they supposedly get discounts on it, to use it. But the
It ain't
version
free.
of
It ain't free.
yeah, but
Nothing's free.
the version of Copilot we have is so vanilla,
Yeah.
um, that it's really better to to use DeepSeek and some of the other platforms that are out there. But we do have an in-house software development team that's actually working on an LLM now, and we've hired a and we pulled her from our computer science department, but she's leading the AI initiatives at the university. A few of us are are a part of are in those meetings. So I've been invited as a community expert. And there's two other librarians that we have that's been invited as community experts to give sort of our take on things. And so yeah, so supposedly by 2026, later on, I think the fall 2026, is supposed to be releasing it. And we do have about 40, we got 43,000 students,
Yeah.
and a lot of staff members. So yeah, from a price point, they couldn't add any more features than what they have from the vanilla version of it. But from my understanding, I think Michigan State is also, well, I know, no, I'm sorry. Michigan, it's either Michigan or Michigan State. I sat on a panel with someone last year that they said that they're working on their own um, LLM also, but they're using Llama as a base.
Yeah.
Um,
And I guess that's really my basic question. So I have a friend of mine who's a head of a economics finance department in the Southwest, and pretty nerdy academic background. Now he has to be administrator, so it's driving him crazy. But he's still trying to keep up with his sort of nerdy side. And I have a friend of mine's son who's NJIT, doing the double masters in comp sci. AI. They don't call it AI, but it's basically AI. And I mean, he's an amazing kid. I'll actually, if you're okay, I'll connect him with you. He's the
oh,
can.
sure.
His name's Cannon Johnson. He was a gymnast at Penn State. He's got literally the greatest sports name of any kid you could have. And he's a cannon, so he's awesome. But so what he's done is just roll like just off the shelf DeepSeek, Llama, Mistral, and slapped it on a desktop workstation. And then my friend just uploads, journal articles and news, anything he can turn into a file, basically. and has built his own little, you know, econ finance lib that's obviously built around his sort of meta model. And it's great. And he just uses RTX 590 cards, which aren't very expensive. Done. Right. And I'm not saying that was like no effort, but it was definitely not like a 2-year project. It was a, 90-day, like not knowing what you're doing from scratch in 90 to 150 days. And, if you did it again, probably 30 days and again, 10 days after that, so I'm just, for whatever reason, I'm just not seeing this. And I don't know. It just sort of, I just find it weird or strange because, I come from the 90s world where, when Linux was just exploding out of the gate and everyone switched from proprietary parallel computing systems to PVM, Linux, kind of scalable, high performance computing, scientific computing systems, right? And I don't know, to me that was obvious, just at a financials level, and also just in a custom tailorization model for what you were really doing. And for whatever reason, I just don't see that right now to the same scale. I'm sure Harvard, MIT, whatever, but I'm just saying like the other 1,000 to 2,000 schools, I just think you can roll your own for, at least tens of K at the low end and probably hundreds of K in the medium end, which just has to be cheaper than buying 50,000 seats, whatever discount
Yeah.
number they're giving you. They ain't charging you 1 penny a month, right, per user. I mean, it's got to be at least $1, or 3 or something, you know.
Yeah, and we have two clusters at Basin. So the power, and we have the team. So that is something that they are working on.
Okay, interesting.
But
So
thank
sorry to monopolize those questions. I've just been, it's like a
no,
pit
no, no, those are good
to
questions.
find somebody to unload them on.
Those are good questions. Thank you.
No, thank you, sir. And once again, thank you for your presentation. It was fantastic.
Thank you.
We're at 3:30, so we're gonna let you ask your question, but that's gonna have to be the last one. Thank you.
Thanks. First of all, Cameron and Aaron, please email me. I'm interested in the same topic about reasoning as both of you. I think we are potentially going in a kind of haphazard, vague direction towards actual reasoning in the form of the mixture of small model experts that Deepseek uses, and I was wondering about Trevor's thoughts on that. Thanks.
Can you repeat that? I'm sorry, Joe.
Do you think that the Deepseek approach of a mixture of small model experts will dominate the future of AI?
Ooh, that's a good question. Oh, I don't know.
I'm thinking the answer is yes, and I'm thinking that's the natural evolutionary step towards the lack of actual reasoning. We still haven't gotten to actual reasoning, but this is a step in that direction because it's less generalized, it's more focused. So I think we're struggling to get past that kind of hurdle to get away from pure statistics to something that's more like actual logical reasoning.
I also think we're closer to an AI winner than a lot of people may think too. When I look at the last two AI winners we've had in the 70s and 80s, I'm seeing a lot of similarities now. So I don't know when that's going to happen, but I think that we're headed in that direction. Which
Trevor, you're that's the whole point. That's actually what the point you're making right now is really the answer to part of what Aaron had to say. Aaron, we've been through 3, 4, maybe 5 AI winners.
I was in the 90s one and didn't know it because I was like 25 or 26.
That's right.
That young, you don't know what's going on, but
there was an AI winner before that, and there was
Yep.
one before that. The natural language processing came before that. The cybernetics one came before that. I did a couple of papers on that stuff. Here's what happens. All of this AI stuff originally started in an academic, scientific, and government context. And the businesses, the entrepreneurs and the venture capitalists, they weren't anywhere near as involved in the process as they are now. And each time we've come in and out of the AI winter, it's kind of been like a feedback kind of loop. The business folks have got more involved at each layer, and so we're now at the layer where the academic folks are not driving this AI hype. The business folks are really, the entrepreneurs and those folks are really driving it like crazy. And so that's why you're not really seeing the engagement at the academic and the scientific level, because the venture capitalists and the big businesses are, it's cart before the horse type scenario. And now that open source has provided so much to the to industry, they want to take advantage of all of that goodwill that's happening in open source. They want to bring it in-house, make it proprietary, and so academic and the scientific environment don't really understand or have the blueprints or the architectures for these systems that are out there. So they don't really even know, what the secret sauce even is or what the architectures actually are, where in the past, those architectures came from academia and they came from the scientific community. Now, these business folks are kind of cobbling their own together. You got a lot of smoke and mirrors going on, and as the academic and scientific community start to look into the horse's mouth, a little bit of truth is starting to come out. And I don't want to take more time up. I do want to respond to something Joe said. Hey, Joe, that statistical stuff, it's necessary on the way to artificial intelligence, but it's not sufficient. We've got to use that to get to a broader concept of automated thinking. We have deductive processes and induction and abduction. We have those kinds of computation. And when you add that computation to statistical inference, you get more powerful there. But we lack a overarching mathematical model for all of it. And we're a long way from that mathematical model. We've got bits and pieces, and the inference, the statistical thing is a part. It's an important part on the way, but it's a long way, man. It's a long, long, long way.
So I would like to thank Trevor again. Excellent presentation.
Excellent guy.
Excellent.
Yeah.
Aaron, thank you for the wonderful comments. And Joe is gone, and there's a lot of participation going on. Julie, thank you for being a great host as usual. And Trevor, you have a last statement that you want to make?
Is he in Abu Dhabi? Is that Abu Dhabi?
No.
I think that's amazing.
Oh, okay.
I might not be allowed back in the country. No, I thank you all for coming. I know, well, at least here it looks like it's nice outside, and we've been out. But yeah, I mean, very excellent comments, and a lot of stuff that y'all have said is give me a lot to think about. So yeah, thank you for not just the questions, but even the conversation afterwards. So I appreciate that.